Hi, I'm Lisa. I will report about the transport layer of the Internet and the application layer of the Internet. Transport layers work transparently within the layers above to deliver and receive data without errors. The send side breaks application messages into segments and passes them onto the network layer. The receiving side then reassembles segments into messages and passes them to the application layer. Basically, that's just a simple idea of how transport layer works. Let me talk about TCP and UDP and a little bit of understanding of it. TCP stands for Transmission Control Protocol. It's the most commonly used protocol on the internet. Say when you load a web page, your computer sends TCP packets to the web server's address, asking you to send the web page to you. The web server responds by sending a stream of TCP packets, which your web browser stitches together to form the web page and display it to your screen. When you click a link or post a comment or do anything else, the web browser sends TCP packets to the server and the server sends TCP packets back. TCP isn't just one-way communication. The remote system sends packets back to acknowledge that it received their packets. TCP guarantees the recipient will receive the data packets in order by numbering them. The recipient sends messages back to the sender saying it received the messages. If the sender doesn't get a correct response, it will resend the packets to ensure the recipient receives them. Packets are also checked for errors. TCP is all about this reliability. Packets sent with TCP are tracked so no data is lost or corrupted in transit. UDP stands for User Datagram Protocol. A datagram is the same thing as a packet of information. The UDP protocol works similarly to TCP, but it throws all error checking stuff out. All the back and forth communication and deliverability guarantees slow things down. When using UDP, packets are just sent to the recipient. The sender won't wait to make sure the recipient receives the packet. It will just continue sending the next packets. If you're the recipient and you miss some of UDP packets, bad news is you can't ask for those packets again. There's no guarantee you're getting all the packets, but losing all this overhead means the computers can communicate more quickly. UDP is used when speed is desirable and error correction isn't necessary. For instance, say in online games, or you're watching a live video stream. Live streams are often broadcast using UDP instead of TCP. The server just sends a constant stream of UDP back into computers and watching. If you lose your connection for a few seconds, then the video will freeze for a moment and then jump to the current beat of the broadcast. Skipping the beats you missed, if you experience minor packets loss, the video or audio may be distorted for a moment as the video continues to play without the missing data. Here are just a few comparisons of TCP and UDP. The connection, reliability that for TCP guarantees that the data transferred remains intact and it will arrive in the same order in which it was sent. But for UDP, it doesn't guarantee that the message or packets will be reachable when you send it. Wait, acknowledgement, and handshakes, or few others. For the application layer of the internet, the five popular internet applications. For one is the DNS, or Domain Name System. It provides mapping between human readable names that we type in a web browser URL field and their associated IP addresses. DNS is like a phone book where you look up the phone numbers listed but easier to remember names. Every domain consists of at least two parts, the actual domain name and the TLD or top level domain. The top level domain are managed in a root zone database like .com, .org, or other two-letter country codes that represent geographic locations. For instance, for Philippines is .ph or Russia is .ru and so on. Imagine when you visit a domain, it follows a series of steps. It begins when you ask your computer to resolve a host name, say for https www.microsoft.com. The first place your computer looks is its local DNS cache, which stores information that your computer has recently retrieved. If the information is not stored locally, your computer queries your ISP's recursive DNS servers. These specialized computers perform the DNS query. Recursive servers have their own cache, so the process usually ends here and the information is returned to the user. But if the recursive servers don't have the answer, they query the root name servers. The root name servers will look at the first part of our request, reading from right to left. So for www.microsoft.com, it will be .com, and direct your query to the top level domain name servers. Then review the next part of the request, Microsoft.com, and direct our query to the name servers again that is responsible for this specific domain. These authoritative name servers are responsible for knowing all the information about the specific domain, which are stored in DNS records. The recursive server retrieves the records from the authoritative name servers and stores the record in its local cache. All records have time to leave value, which is like an expiration date. After a while, the recursive server will need to ask for a new copy of the record to make sure the information doesn't become out of date. With all the answers, the recursive server returns the record back to your computer. Your computer stores the record in its cache, reads the IP address from the record, then passes this information to your browser. The browser then opens a connection to the web server and receives the website. The next is Telnet. It is a protocol that allows you to connect to remote computers over a TCP/IP network. Using Telnet client software on your computer, you can make a connection to a Telnet server. Once your Telnet client establishes a connection to the remote host, your client becomes a virtual terminal, allowing you to communicate with the remote host from your computer. In most cases, you'll need to log into the remote host, which requires that you have an account on that system. Third is the www or World Wide Web. The Internet is a network. The World Wide Web is an application that works with the Internet. The World Wide Web, or Web for short, works on the HTTP protocol. The web is a client-server application. The servers are connected to the web and listen for requests via the Internet. These web servers are running on HTTP server. It is the job of the web server to receive requests and formulate responses to those requests. The URL tells which document to use in the response. The URL consists of a protocol name, DNS name, and file name. The server retrieves the indicated file name or document and formulates a response which is sent back to the client. Clients are the web browsers like Internet Explorer or Firefox or Google Chrome. It is the job of these browsers to render the page for the user. It then waits for either a link to be clicked on or an URL to be entered into the URL entry area. It then formulates an HTTP request which it passes to the server via the Internet. It waits for a response. When it receives the response, it renders the page to the user. The whole cycle consists of a request followed by a response. The file transfer protocol. It is used to transfer files between two computers over a network and internet. When you want to copy files between two computers that are on the same local network, often you can simply share a drive or folder and copy the files the same way you would copy files from one place to another on your own PC. But what if you want to copy files from one computer to another side of the world? You would for sure use your internet connection. However, for security reasons, it is very uncommon to share folders over the internet. File transfers over the internet use special techniques. So there is the FTP. It can transfer files between any computers that have an internet connection and also works between computers using totally different operating systems. Of course, connecting to an FTP server is similar to connecting to just about any other server in the web. When you log into your email account or a secure shopping website, you have to provide a server address, a username, and a password before you can exchange information with the server. Next, and lastly, is the electronic mail. Email systems consist of computer servers that process and store messages on behalf of users who connect to the email infrastructure via an email client or web interface. Email servers are responsible for receiving, storing, forwarding, and delivering messages to and from email users. Messages are exchanged between servers using the Simple Message Transfer Protocol, or SMTP, with various mail transfer agents. A user can access the email messages stored on an email server using an email client or mail user agent, such as Outlook. The MUA connects to the mail server via Post Office Protocol or POP to download messages from a folder, or the more advanced Internet Message Access Protocol to synchronize all messages in the folders that exist on the server. When the user sends a message, the client connects to the server using the SMTP protocol. The actual email message contains text and characters that represents delivery information and content, and must adhere to certain standards to ensure that it can be properly handled by the various computer systems that will process it. Lastly, all email message consists of two main sections, the header and the body. That's it. Thank you.